This is the 3.3 to 3.5 review. Calculators are not allowed, and the goal on all three problems is to evaluate the derivative at pi over 3. So this job, or this particular problem, will involve both the chain rule and your knowledge of trig rules. So if we look here at f of x equals secant of 2x, in order to take the derivative, we need to know the derivative rule for secant and for its interior function 2x. So the derivative of secant is secant times tangent, and the inside of the original does not change. Now we've taken the derivative of the secant. The next thing we take the derivative of is the 2x. So we multiply by 2 at the back. Simplify, we can bring that 2 to the front, and we get 2 secant of 2x times the tangent of 2x. Now our job is to evaluate this at pi over 3 now that we have found the derivative. So that will be 2 times the secant of 2 pi over 3 times the tangent of 2 pi over 3. Now notice in my answer key that I do not leave it like this, which means you need to know your unit circle and how to read that information off of the unit circle. So let's remember that unit circles are easy to read sine and cosine, so those are the y coordinates and the x coordinates of points. Secants and tangents are a little trickier. So we're going to rewrite these as sines and cosines to perhaps make the problem simpler. Secant is 1 over cosine, and tangent is sine over cosine. So if we think about our unit circle, 2 pi over 3 is here. So the sine will be the y coordinate, which is a root 3 over 2, and the cosine will be the x coordinate, which is a negative 1/2. So if I put this in here, I have 2 times a 1 over a negative 1/2 times a root 3 over 2 over a negative 1/2. If we simplify this now, we can see that we get on top, this 2 will cancel with this one, so I have a root 3, and on the bottom I have a positive 1/4, and dividing by 1/4 is the same as multiplying by 4. So my correct answer would be 4 root 3. Now let's look at B. B, the first rule that I will have to apply is the product rule, because I have two functions that are multiplied together. So the derivative will be the first one times the derivative of the second plus the second times the derivative of the first. So derivative of the first, I could take the derivative of sine pretty readily and get here. Derivative of the second, I have to do the chain rule because I see that I have a cosine rule and a power rule. So the derivative of the cosine is negative sine of the inside unchanged times the derivative of the inside. So my next job is to now evaluate this f prime at pi over 3. So I will plug in pi over 3. That gives me the sine of pi over 3. Again, let's go back to our unit circle. Pi over 3 is here. So the sine of it is the y coordinate, which is a root 3 over 2, times, this will be the sine of 2 pi over 3. So that's over here. That will be a negative root 3 over 2 times the 2 plus the cosine of 2 pi over 3, which we saw up here was a negative 1/2, times the cosine of positive root pi over 3, which is a positive 1/2. So if I put this all together, I end up with, it looks like a 2 will cancel, the 3's will multiply, I'll get a negative 3 over 2 minus a 1 over 4. So I'll get a common denominator. I have a negative 6 minus 1, that's a negative 7 over 4. Last one, C. I want to take the derivative first. And the first rule I see is the root or the radical, so that's a power rule. It'll be 1/2 times the inside unchanged raised to the negative 1/2 times the derivative of the inside, which in this case will be cosine. So derivative of cosine is sine of x. Again, we need to compute this at pi over 3. So f prime of pi over 3 will be 1/2 times 1 over the square root of the cosine of pi over 3, which is 1/2, times the sine of pi over 3, which is root 3 over 2. So now to simplify this, we need to first realize that dividing by the square root of 1/2 is the same as multiplying by the reciprocal of that, which is a root 2, times a root 3 over 2. We can see on the top that we get a root 6, and on the bottom we get a 4. And we neglected the derivative of cosine is negative sine. So we end up with a negative. Sorry about that. And we're done.